You built a RAG system. You embedded your docs. You search and get garbage results. The LLM hallucinates anyway. Most people blame the model, but the real problem happened before any search ran. You chunked your documents wrong. Chunk too big, the embedding is diluted. Chunk too small, you lose the context that makes the answer useful. This video shows you exactly how to chunk your documents so retrieval actually works. Here's the basic idea. You have a 10-page document, a refund policy, a product spec, whatever. You can't embed the whole thing as one vector. The embedding model has a token limit, usually 512 or 8,192 tokens, depending on the model. Even if it fits, one embedding for 10 pages captures nothing specific. So you split the document into smaller pieces. Each piece is a chunk. Each chunk gets its own embedding. Now when someone searches annual plan refund, the search finds the specific chunk about annual plan refunds, not a vague summary of the entire document. That's chunking. The question is, how do you decide where to split? Let's see why size matters. Take a refund policy document. If you chunk the whole page as one block, that's 2,000 tokens. When someone searches annual plan refund, the embedding matches loosely. Similarity score 0.61. Too much unrelated content dilutes the signal. Now go the other extreme. Chunk every single sentence, 20 tokens each. The search finds annual plans may be refunded. Similarity 0.89. But the chunk has zero context. Refunded how? Under what conditions? The LLM can't answer the actual question. The sweet spot is paragraph level, 200 to 500 tokens. The search hits section 4.2, the paragraph about annual plan refunds specifically. Similarity 0.94. Enough detail to answer the question, enough context for the LLM to generate a complete response. There's another problem. When you split a document into chunks, you create hard boundaries. Information that spans two chunks gets cut in half. Take this example. One paragraph says, annual plans are eligible for refunds. The next paragraph says, subject to a 2-month usage deduction. If your chunk boundary falls between those two sentences, neither chunk has the full answer. The fix is overlap. You set a chunk size of 400 tokens and an overlap of 50 tokens. The last 50 tokens of chunk 1 repeat as the first 50 tokens of chunk 2. Now both chunks contain eligible for refunds subject to a 2-month usage deduction. The search can find the complete answer regardless of which chunk it hits. Typical overlap is 10 to 20% of chunk size. If you want to learn how to do this yourself, I run free live sessions every Friday at noon Eastern. Scan the QR code on screen to join. Would love to see you there. The simplest approach is fixed-size chunking. You pick a number, 500 tokens. You split the document every 500 tokens. That's it. No logic about paragraphs, sentences, or meaning. Just count to 500 and cut. The advantage is predictability. Every chunk is the same size. Easy to implement, easy to debug, easy to reason about storage costs. The downside is obvious. You might cut in the middle of a sentence. Annual plans are eligible for in one chunk, refunds subject to conditions in the next. Neither chunk makes complete sense on its own. Fixed size works fine for homogeneous content like log files or structured data. For natural language documents, you want something smarter. This is the technique you'll use 80% of the time. Recursive character chunking. Here's how it works. You give it a list of separators in priority order. Double new line, single new line, period space, space. The algorithm tries to split on double new lines first. Those are paragraph boundaries. If a resulting chunk is still too big, it falls back to single new lines. Still too big? Split on sentences. Last resort, split on spaces. Take our refund policy. The double new line split gives us 4 clean paragraphs. Section 1 is 280 tokens, fits perfectly. Section 2 is 180 tokens, fine. Section 3 is 620 tokens, too big. So it falls back to sentence splitting on that section only. Now Section 3 becomes two chunks, 3A at 340 tokens and 3B at 280 tokens. Every chunk respects natural boundaries, no mid-sentence cuts. This is the default in LangChain, Llama Index, and most RAG frameworks. Semantic chunking takes a completely different approach. Instead of splitting by character count or punctuation, it splits by meaning. Here's the idea. You take every sentence and compute its embedding. Then you compare adjacent sentences. If two sentences have high cosine similarity, they belong in the same chunk. When the similarity drops below a threshold, you create a new chunk boundary. Take a product spec. Sentences about pricing cluster together. Sentences about features cluster together. The algorithm detects the semantic shift and splits there. The result is chunks that are topically coherent. Every chunk is about one thing. The downside is cost. You're calling the embedding model for every sentence, not just every chunk. For most use cases, recursive character chunking gives you 90% of the benefit at a fraction of the cost. Here's how to choose. Start with recursive character chunking. Chunk size 400 to 600 tokens, overlap 50 to 100. That's your baseline. If your documents are structured, like code files, log entries, or CSV data, fixed size chunking is fine. If your retrieval quality still isn't good enough after recursive chunking, try semantic chunking on the problem documents. And always measure. Run the same 20 test queries against each strategy. Compare the similarity scores. The right chunking strategy is the one that puts the right information in front of the LLM. That's the full picture. If you want to go deeper, join my free live session this Friday at noon Eastern on Maven. I walk through this hands-on, answer questions, and show you how to build it yourself. Scan the QR code to join.